let's take a look at today's lecture. I put more reshaping. This is actually not the right thing. I should just say more on like extracting data, I would say. So this is still coming from chapter 6, and I do want to make sure you guys are reading your textbook. I don't know how to enforce this other than telling you. There's no enforcement. There's no way I can tell if you actually read it, but I will tell you there's good stuff in there. And
you say that there's stuff from the final that's going to test us on the textbook reading.
But that's not true. Reading. That's not true. I'm not.
It's a white lie.
I don't like to lie. Okay. All right. So we got Tibbles, and you're already familiar with select. There's also, and I need to cover square bracket notation. This is a way for us to select data out of a tibble or a data frame. And you guys have been using a lot of stuff like select and filter already, and those are great tools. Those are part of the tidyverse. That's not part of base R. So if somebody says, "Oh, here's this thing in base R," and then you try to use select, you might it's going to tell you like, "I don't know how to do select," right? It's going to be like function not found and stuff.
It's within like dplyr within tidyverse.
Dplyr is part of tidyverse, right. and select and filter are part of our things that are inside of dplyr. Yeah.
What's the dbplyr thing that I see every so often?
dbplyr?
Yeah. Is that the same database?
It's probably dplyr, but adapted for another data structure. I don't know off the top of my head. Where do you see it?
Like sometimes when I run my code, it'll just say like replacing.
dbplyr is the database backend for dplyr. Allows you to remove. Okay. Oh, okay. So it just takes dplyr code and it turns it into SQL code, and allows you to interact with databases that way. Okay. There is a lot of overlap between a lot of concepts in SQL or SQL and dplyr. The verbs are a little bit different. SQL you have select, and then you filter using where.
From.
It's from. There's no from in dplyr. You just kind of pipe your table into it. But so there's some overlap, but not exactly the same. And I guess dbplyr provides a translation
It allows
system.
you to use SQL on R?
Yeah, there's lots of things that allow you to use SQL on R, but that's outside the scope of this class. But yeah.
What class would cover this kind of stuff?
I don't know.
Okay.
What class would cover SQL? Probably teach yourself, I would say. So I cover SQL a little bit in. Where do I cover it? I don't know anymore. Stats 21. I used to not.
Python course?
Maybe not. Okay. Yeah.
Data camp.
So did I say this? There's a big difference between learning.
SQL. There's 2 routes of SQL.
Yeah, I mean, just learning how to query SQL, like how to extract information versus like setting up a database. So you can, I would say, search some tutorials online and you can probably learn how to query SQL in a few hours.
30 minutes.
Yeah. Yeah. I'm highly suspicious. Sometimes you'll see these like boot camps. Teach yourself become a data scientist in 6 weeks or something, and it's like, oh, we're gonna fit all of calculus in 1 week, or I don't. I'm not sure about that.
You could do it. I don't know how effective it would be.
Yeah.
The 40-minute video once it summed out all of Calc 1 and 2 really well.
Yeah, but that's already assuming you've taken a full course on Calc 1 and Calc 2. And you can say you just need a 40-minute refresher. Sure, that could work, but can you imagine like you enroll in a class and then your final exam is in 40 minutes? I don't think that's going to work. Get your undergraduate degree. Okay. So anyway, we're going to. I mean, I guess that's the plan of certain for-profit schools, right? It's just kind of like, give us your money and we'll give you a degree.
Yeah. Here's a piece of paper.
And it's definitely different. system. Okay, just to show you how we're going to work with this, here's a very, very simple table or tibble. Okay, I've got 3 columns, X, Y, and Z, and 4 rows. The row X has 1, 2, 3, 4, Y has A, B, C, D, and Z has 100, 200, 300, 400. So it's very simple, so you can kind of see what's going to happen. And here, let me move this over here. So here's our data frame. This is what it looks like. And if you just want to select a row, you can use slice. Here, let me expand this. So slice will just select that one row. You can also, this is square bracket notation, and when you use a square bracket, you put basically a number, comma, number, comma, number. And the number in front of the comma is which row you want. So here I put a 2. It's kind of like you have some kind of grid, right? Like an XY coordinate almost, except the number in front is which row, and the second number is which column, okay? And you just have to get used to that, because you might feel like, oh, I want to do columns first and then rows. It's always row, then column, and that's fairly widespread, that kind of notation, row first, then comma. And so here, if you want just row 2, and if you leave the part after the comma blank, it's going to assume you want all the columns. Okay, so this means row 2, all the columns, and you're going to get the same thing. So slice 2 is give me the second row, and square bracket 2 comma is also give me the second row. You can put in a little vector, okay, and we know how to work with vectors and create vectors, and so you can put in basically which row numbers you want, and you can put that inside slice, and it will give you those rows, and it will give it in the order that you asked for. So here, if I say slice, and I give it the vector 3, 2, it will give me row 3 followed by row 2, okay? And you can repeat. I can do 3, 3, 2, 2, and it will repeat row 3, row 3, row 2, row 2, okay? It's just like whatever list you give it, it's just going to pull that thing out, right? So if you give somebody a grocery list and say, I want 3 gallons of milk, you'll get 3 gallons of milk type of thing. Yeah.
If you wanted like a range, would you do like 2
colon yeah
4 or something?
Yeah, you can give it a range. You can do 2 100, okay, things like that. If you give it something that doesn't exist, then you'll run into
error.
Well, now I'm not sure.
Let's find out.
I think
if you do 2 to 3, would it include the third number, like 3?
Yeah, it'll include the 3. This behavior is different from like Python behavior. So Python stops before
it
your.
also counts from 1.
Yeah, R counts from 1. So yeah, don't expect it to be the same as Python. Okay, there's similarities, but also differences. So, all right, let's get this. All right, so here's df. Okay, so the question was, what happens if I try to select something that isn't it? Okay, so df slice 5. Okay, so we get a tibble with 0 rows.
So it does run.
It runs, no error, but you get nothing, okay? All right, let's try square bracket notation, ask for the 5th row. Okay, same. I get, not the same. I get a row, a tibble with 1 row full of NAs. Okay, interesting. Okay, all right, well, now we know. And so let's try df2, 6 or 2 6, 2, 3, 4 NA, and let's see what happens when I slice. So there are subtle differences. 2 through 6. So when you slice it, it pulls out just 2, 3, 4, and then nothing for rows 5 and 6. Okay. All right. Well, you know what? These are good examples to include. So subsetting multiple rows. I'll put this in for the next class that gets it, or I suppose.
Oh, our legacy.
All right, yeah, df. It's all right. There is a difference when selecting rows that do not exist. Okay, so we've got df slice 2 through 6 versus df 2 through 6 this. Okay, so this returns a data frame with NAs in the rows that do not exist. Okay, does not return anything. All right, let's. This is how I do my job. Okay. Renit.
So does it just auto format in the way you want it to?
Yeah, I've set up a template and
Well,
all right, so here you go. Okay. Oh, you know what? I need to just do a little bit. I need to change my font size here. Okay.
Inspired by the class data.
Well, you asked good questions, so we'll throw it in here. Okay. Huh? So there you go. So there's a difference, and so now you can see that 2, 3, 4 doesn't return anything for the rows, or I shouldn't say doesn't return anything. Doesn't return anything for rows that don't exist. Okay. Was there a question? Yeah.
Isn't there also a dollar sign sort of syntax?
Yes, there's $ notation that's coming up. Coming right up. Okay. You are anticipating the content of the day. Okay. So that is selecting rows, and yes, I guess there is a difference between slice and using square bracket notation here. Okay. How do you select a column? Well, you use select instead of slice. So slice is for the rows, select is for the columns. And you've already know how to select columns based on the name of the column. So you select X, select Y, or things like that. And here you can also give it the column number. So our columns were X, Y, Z. So you can say select column 2, and that's going to be the second column. Okay. Similarly, you can use square bracket notation. And you can say df square bracket comma 2, okay, and this will select the second column. So both of these things return the same thing. You can also select multiple columns. So here I've got select 2:3, and that will select the second and third columns. And then df square bracket comma 2:3. So again, the value after the comma is which columns you want. The value before you is which rows you want. Yeah, question?
Okay. Can we understand select as selecting for columns where slice is for rows, and then what about for filter? Is filter also?
Filters, okay, so slice is selecting rows based on row number. Filter is selecting rows based on a condition. So you'll do like filter where weight is over 200, okay? And then that will select only the rows where that column weight is greater than 200. Or something like that.
So
okay?
rows, but by
it's rows based on a condition. Okay. Slice is selecting rows based on row number.
Okay. Got it. Thank you.
You can specify coordinates. Oh, this got a little bit messed up here. So let's say, here's my table. Okay, let's say I wanted to get this number 200 out of here. Okay, so a lot of times maybe you've done a summarize. Right, and one of the columns is the mean, and you have group A's mean, group B's mean, group C's mean, or something like that. And you want to just say like, oh, I want group B's mean or something. Okay, so you can specify this, and you can go by coordinates. You can say row 2, column 3, right? Row 2, column 3, and so you can just do df square bracket 2, 3. Here you can do select column 3. And slice out row 2, or the second item. Okay, so you can use a combination of a select slice to get out the same thing. So, but basically, I'm just showing you like multiple ways to do the same thing. Just because sometimes you'll be reading someone else's code, and it'll be confusing because you're seeing them do things that you're not familiar with. So. I would say the square bracket notation is very common out there, so I just want you to be familiar with it. Yeah, question?
Can you like pipe out of the square bracket?
Pipe out, well, okay, so you can take this and pipe it somewhere else, and basically you have this thing. So you can, whatever you have, you can then pipe to another thing. There's certain one. So I guess as long as you have a tibble, you can pipe it into something. But then once it's no longer a tibble, then you might be able to pipe it. You might not be able to pipe it. I would say. Okay. I guess even to the tibble rule, it depends what function comes next. I would say. So.
What does piping out mean?
I mean, just kind of take the result and do something next with it. Okay. Now. With the tibble, though, it's a tibble, and sometimes you just want this number 200, actually. And so for that, we have to extract out the values, okay? Because when it's a tibble and you try to do stuff with a tibble, the result that you get back is going to be a tibble. It's going to be basically you have this two-dimensional structure where it says here's the row and here's the column, and it might be like this one is. It's a two-dimensional structure, but we just say there's one row and one column, okay? And there's only one number in there. And sometimes you just want that number. Like you want to take that number and you want to take the square root of it or something. You want to do something with this thing, and you don't actually want, like, here's a 1-by-1 table with one single number in there, okay? So how do you get that out? That's called extracting, okay? And again, just like everything else we're looking at, there's lots of ways to do this. And before I forget, let me give you your first view quiz answer. I think I've corrected Wednesday's mistake with the wrong thing, so it should be fixed. But okay, Friday,
Yep.
Question 1,
Grades are fixed.
answer is C as in cat. C as in cat is your first.
Are you sure about that?
Yeah, right? I mean, if I make a mistake, I'll fix it again, right? It's not.
Yeah, the grade
Okay.
has been changed.
Okay, C as in cat is your first view quiz answer for Friday, today.
You did that?
Right on time.
Yeah, you got it. Okay. So method 1, extracting vectors. You can use double square bracket notation. So sometimes you'll see double square brackets in people's code, and this pulls out basically one column. This is technically not 100% true, but generally you should only put one number in the double square bracket. If you put multiple numbers in the double square bracket, like a little vector in there, it has different behavior. It has a recursive behavior, which, like, if you understand exactly what it's doing, it's fine, but it's a little bit confusing for a lot of people. So basically, double square bracket with a 2 inside says I want to extract the number values from the second column, and this is going to return basically a vector. So it's not over here when we said I want the second column, it returned back a table with 4 rows and 1 column. And here, it's just giving me a vector of those values, A, B, C, D. There's no table structure here. There's no rows, there's no columns. It's just, here's the values, A, B, C, D. And so let's say you want the letter C. You just want this one thing. And again, here I'm doing it with letters, but you can do it just as easily with a column of values. Okay, so you use double square bracket to get that second column, and then you chain it with a single square bracket to get out, say, the third value. Okay, and so this will just give you back that one value, which is the letter C, or whatever number, 200, or whatever it is that you're looking for. Question?
Yeah, when would you want to print out a vector as opposed to having a tibble, like the example you showed earlier?
I mean, the answer is always it depends. Yes, I mean, sometimes you just want the numbers, not necessarily in a table structure, for whatever reason,
I guess
yeah.
Is there an advantage? It's
Well,
faster speed.
so a vector is just a vector of values, and you can do like
One dimension.
vectorized. Yeah, it's a one-dimensional structure, and you can do operations with it. Okay. All right. So here I'm chaining the single square bracket after the double square bracket. So that's one way to extract out values. Okay. Another method is you can use $ notation. So this requires that your columns have names, which generally they should. and you would do $sign and the name of the column. So $Z is that third column, which is 100, 200, 300, 400. Again, when you use the $sign notation, it doesn't return a table with 4 rows and 1 column. It's just going to return the values in a vector. So here I get the values in a vector, and then if you want to extract out or subset, select any of these values in here, you can chain a single square bracket after it, put in whatever numbers you want. Here I'm saying I want numbers 2 and 3 in this thing, so it pulls out 200 and 300. And again, if you just want 1, you just put in a single square bracket. Yeah.
If you don't name your columns, wouldn't R also automatically assign you with 1?
Yeah, I think R automatically, if you don't name them, well, like let's say you read in a CSV file or something, I think it automatically names it like V1, V2.
And then you would use V1.
And then you would use V1 and V2 as your names.
$.
Yeah,
Okay.
yeah. And then if you have bad names, like names that start with start with a number or something, it might throw in like an X in front of it, and so like the baseball data, you had like X2B because it doesn't want a column named 2B, something like that.
You also said having periods in there would be bad.
Yeah. You generally don't want to put dots inside your column names. People do it, but use an underscore instead. Yes.
If you use 2 commas, can you use some that's simple?
No, not if you want to use a comma. Like let's say you wanted like the second row and the 4th row, you'd have to put that inside a vector. You'd have to use C.
Oh, okay.
So I have an example of that, like over here, right? C and then 2 comma 4 or something like that. So if you want multiple values, you have to kind of group them together into a single entity. Otherwise, it like,
Square brackets, right?
huh?
Within the square bracket.
Yeah, within the square bracket, yeah. Okay, and then the last is, or another method. There's probably even more methods, but I would say these are probably the ones you'll encounter most frequently. Is if you're going dplyr, there's a method called pull, or a function called pull. So here you can, after you select the column. So remember, the result of select is going to be a table structure, right? So you have 4 rows and 1 column, and if you want to turn that into a vector, there's a function called pull, and it's going to pull the values out and just make a vector out of it. Okay. If you want to select only a couple of those values, you'll slice it and then pull it. So here I'm selecting the 3rd column, I'm slicing it just down to the 2nd and 3rd values in that column, and then I'm going to pull it. Okay. So is that good? Does that kind of make sense as far as what we're trying to achieve here? Yeah.
If you're using pull, do you have to have a single column?
Yeah. Well, let me see. What happens if I try using pull on something that is not, like if I try to pipe this into pull?
Why would it automatically choose the last one?
I don't know. Okay. Well, yeah. So basically, so R is a language that you ask it something. If you give it ambiguous direction, well, okay, it depends. But basically, if you give it something, it's gonna just do its best. All right. And sometimes that means what often that means is when you read code that wasn't well written, you'll be like, is this going to work or is this going to result in an error? And sometimes it works, but the behavior is not quite what you expected, right? So here, like if let's say I select the 2nd and 3rd columns, and then I say pull. Okay, what is it going to do? Apparently, it just pulls out the last column that I selected. Okay, but that's like weird, right? Is that what I wanted? So I would say pull is best used when you have just 1 column, but Well, I don't know what happened. Like if I do 3 comma 2, yeah. Okay, so this time because I did 3 comma 2, the last column is A B C D, and I did pull. It's going to pull out that last column. So I guess pull is going to pull the last column. Let's see. Let's ask for questions about pull. Pull is similar to $, and it can name the thing variable. The default returns the last column on the assumption that's the column you've created most recently. Oh, okay. I guess that makes sense. So like if you did df and you did a mutate, like you did z divided by 4 or something like that, and then you just demutate pull, it's going to pull out that last column. Okay. So okay. So you read the help and it tells you like what it's going to do. So okay. The default returns the last column on the assumption that was okay. I guess that's a reasonable assumption. Okay. Well, now we know. Now we know. I always thought just select one column, but maybe we'll add that to the notes. Subsetting multiple rows, extracting vectors. Okay, notes on pull. Okay, so we'll say default. I'll have to fix this. Okay, let's talk about data intake. Most of the time you'll probably just use read underscore CSV, I guess under the assumption that a lot of data is transported using CSVs. So you go out on the internet and you look for a data file. A lot of times the data is available as a CSV file. I would say that's probably the most common thing. CSV means comma separated values, and that means you can just open it up with, say, like Notepad, and it will look like, let me see if I can find a simple CSV file. Okay. So if I open this in Excel, so Excel knows how to read CSV files, right? So here are 2 columns of data, and you have all of these things. But underneath, it's a plain text file. And if I say open it with Notepad, this is what it looks like. It says chemical, comma, magnetic, 24, comma, 25, 16, comma, 22, and so on and so forth. And this is fairly easy because there's only 2 columns. But let's see. Here's something a little bit more complicated. 1959, quarter 1, real GDP, multiple values. And if you were to read this into open the text file, it looks like this, and it just hurts your eyes to read. But a computer can read this quite easily, okay? So, to read data in like that, you would use read underscore CSV, and that's gonna load up CSV files. Then you also have similar things, tab separated files. You have just some general delimited file if you use, say, like semicolons to separate your things. There's also fixed width files. Let me see if I can find an example of a fixed width data file. Okay, so sometimes you'll have data where it's like people put spaces, right? So the data file will look like this. And this is kind of made so it's a little bit more human readable, where people put like a whole bunch of spaces to kind of separate out the columns. And so a fixed width file is usually easier to read as a human, and it can do stuff like this. Okay, and so anyway, you have a bunch of these different types of files. there's a cheat sheet that tells you how to read in all of this stuff, okay? Sometimes you have data coming from other softwares, and so yeah, readr is for kind of your general things. But if you say if you have Excel files, .xls, .xlsx or whatever, you have these Excel files. You can use read Excel. And if you have some other stats software like SAS or SPSS or Stata, that can be, you can often read that in using a package called Haven. And then if you have like massive data, I would say, over over a few hundred megabytes. So I'd say over a couple hundred megabytes, then you might want to consider using data.table. So data.table uses kind of, it's, so if your CSV file is like over 200 megabytes, then I would say, use data.table. It's got a different kind of core underneath that has it process a bit faster than readr. Readr is pretty good, but if you have big ones, okay? And you can read more, again, help on any of these things. Look at this. Oh, they used Clippy as the icon here. I think you guys are too young to know who Clippy is.
I remember it from my mom's computer back when I was like in second grade.
Sure.
Came up for me in Crimes Against Humanity 2 days ago. Nobody else at the table recognized it. It was sad.
For us older people. Okay, so data table has this has a function called fread, like fast reader, and it works very much like read CSV. And I guess here I wrote, if you have a massive data file like something over 1 gigabyte, that's the way to go. I would say even a few hundred megabytes probably good. And then what's the difference? It's just faster, and there's a few other differences. Don't worry about it. Okay. This is how you would read in Excel files. So if you have like a .xls or .xlsx, you would read that in. Excel files, you can actually have multiple like worksheets, right? You can have like different sheets and stuff. And so you can specify which, so by default, it's only going to import the first worksheet. But if you want, you can specify, I want sheet number 2, or you can specify the sheet by name if you know what those things are. Okay, let me give you your next view quiz answer. Is the letter B as in bear. B as in bear. Okay, so B. All right, there we go. And then, one more question.
Yeah, if you wanted to load something on your computer, I think you already showed it, but how would you? It was kind of like our first homework assignment where you had to import an image from our local file on our hard drive.
Uh-huh.
How would you do that with a CSV?
Okay, wait. So images are different.
Yeah, if you like an Excel file.
An Excel thing, yeah. So the default is wherever wherever you're working, your working directory. So I recommend you create a folder where you're going to be doing like your homework. Like create a folder for homework 1, create a separate folder for homework 2, create a separate folder for homework 3, create a separate separate folder for your project, right? Yeah. And then inside that folder, create your RMD file that you're working on, and then put all related files into that same folder. And by default, R is going to look, when you say, here's a data file, datasets.xls, it's going to check the same folder that your file is in, okay? And if you do it that way, there's no kind of confusion, okay? And you might have encountered problems when if you downloaded the image and it goes into your downloads folder, but your homework file was in, homework 1 folder, and then those are separate things and it doesn't know how to like locate it, right? So if you insist, right, and it's not wrong to do it, but it's just, it makes it harder, is you can create what's called an absolute path. an absolute path will start off with like C:/ users / miles / downloads / stuff like that, and you can set the absolute path and it will be able to find it. Okay, when you type a web address into the internet, that's one kind of absolute path. www.amazon.com / product / whatever it is, and you can find the I can give that address to someone else and they can find the exact same thing I'm talking about because it's an absolute path. But sometimes those paths get really long, so long that we don't want to type them out, and now we have to represent them with little QR codes, and because that's much easier, right? But here we don't get the option of like, oh, I'm going to put a little QR code for this file located on my hard drive. So just put it in the same folder, and then you can give it what's called a relative path. All right, you just say, hey, look for this, right? So it's kind of just like if we're in this building and I say go to room 3699, you're going to assume, okay, we're talking about this building and this thing, right? Mm-hmm. If you're on campus, you can say, okay, go to geology 3659 or whatever, and people might know. But then if you're like somewhere in the world, then you have to say, okay, go to whatever, you write your mailing address or whatever, and it's like United States, California, zip code this and this, and then this camp, this location and something like that, right? It's kind of like, how specific do you have to be with the address? Usually we want to be lazy and write a short path, and that's fine as long as like things are locally located here. Okay. There is a package called Downloader, and this allows you to kind of download files off of the internet. R has some basic download capabilities, but it only works if it's not secure. And pretty much like the standard these days is every web address you go onto now has an S in there and a little lock icon appears. And that's just because there were too many bad people out there that we decided this is now needed. So use library downloader, and this will now kind of allow you to access things that are secure. And so here I have the Iris CSV file, I think. So here's CSV file, and if you wanted to read this in, you can download this. Okay, so you specify the URL, universal resource locator something. Okay, and you can click download that file, and this is going to save this file into your hard drive, and then you can then read that file in. So that's Downloader if you need to work off of things off the internet. Okay, if you have a data frame, you can then export it and give it to someone else. And probably the one you'll use is going to be write.csv. Okay, so you have a data frame and you're going to save it to a CSV file. By default, it's going to save the row names like row 1, row 2, row 3. And if you don't want that, you would do row names equals false. Yeah, question?
For the downloading, what is like the case where we can download from like a website and actually like pull a file from the website? Is it just like pulling HTML or? Not
the HTML. So this is assuming the data is, so like if you go to say GitHub, there is going to be basically a lot of kind of repositories out there where the data, you can find like the raw data. So, for here I have, CSV file, and this is what it looks like. And if you click raw, it looks like this. And let's say you wanted to like work with this. This is the CSV file directly, and you can work with it. Yeah. Okay. Sometimes you have, and I didn't cover this. I didn't put it in the slides, but it's in the textbook. You can go to Wikipedia, right? And I don't know. You go U.S. states by population, list of U.S. states and territories by population, right? And you have this table, and you want to read this in. You can you can read this in, and there's an example of it in the textbook. There's a package called rvest, and that allows you to kind of read in HTML tables. Okay, but it has to be like nicely formatted. But yeah, I mean, if you go to say like baseball reference, and okay, so let's look up say the Yankees or something. So here is, we can go to export, and you can do get as Excel, get as CSV. Oh, okay. Well, that's not great.
Yesterday's stats.
But we'll, I guess. Okay, I guess you'd have to select this and paste it into a file and save it as a CSV. Let's see.
You save the text
Get
file
link
as
to the table. Let's see, copy to clipboard. No, that's just going to link me to that table. I'm sorry?
Can you like open a text file?
Yeah,
and
so
save it?
if I wanted to do this, I would create a new text file. And so if you see data like this, you would just kind of, whoops, okay. I would copy, Control C, come over here, Control V, and then, I don't want, this would be, well, I don't think I want the team totals, okay? And then I'm gonna click File, Save As, and we are in the Stats 15 folder under Lectures, Week 4. Okay, so, and I would, you would save it as,
CSV.
so under all types, I would put in, I'll call this Yankees.csv, okay? And so if so again, when you name it, you're gonna have to call .csv when you name it. And so this is now saved in my Stats 15 folder. What did I say? Lectures, Week 4. Okay, so here it is under Yankees.csv, and we can see it loads up in Excel, so this is a good sign. And then in R, let me see. Okay, so I need to set my working directory to my source file location. So this is what we want. And then I would do create I'm gonna call read_CSV, and I give it the name Yankees.csv, okay? And it looks like it read in, and so now I can ask what is Yankees, and we've got this, and I can do whatever we want, right? So I could say, what is Yankees $age, and what's the mean? Okay, 29.2 years old or something, right? Who's the oldest player? Okay, 36, 22 for youngest and oldest or something like that, right? Okay. So that's what we have. Okay. All right, and I'm out of time. There's one more thing. There's something called package, lubridate. Again, everybody tries to be cute with their naming of things. So it's lubricate to make things go smoother, okay? And but it works with dates, and because dates are a weird thing. They are underneath it all. They're numeric variables because you can compare two dates and say this one is earlier or later in time. But because of the formatting, there's like weird ways to specify a date, right? You can have January 15th, 1999, December 15th, 2001, and so on and so forth. And you'd have to, if you weren't using lubridate, you have to specify this format string, and it gets very complicated and it's very finicky. And if you make like one little mistake, you're going to get a bunch of NAs instead of the actual date that you want. And so so here I just showed you like these slides that say without lubridate are just to show you how frustrating it is to work with date objects without lubridate. And lubridate all you have to do is, so you can have different formatted strings, January 15, 1999, December 15, 2001, March 18, 2002, and all you have to do is say, hey, this is in the US where we do month, day, year, and it will figure it out, okay? You can't mix like US and European formats because, you know, something like, well, none of these dates are ambiguous, but if you had like 7-8-19, like that's ambiguous, right? So you have to specify, is it month, day, year, or is it day, month, year, things like that. So if you specify that, lubridate will handle the rest, which is really nice because the old way of working with dates was very frustrating. So if you have to work with data information, use lubridate, read up the help on how to do lubridate. Okay, last view quiz answer. Last view quiz answer is E as in elephant. E as in elephant. E. Okay. That's that. I have this thing on recoding values. Maybe we'll take a look at it next week or not. But okay. All right. That's it for today. We'll see you. Have a great weekend. See you Monday.